Hey everybody, you're joining me a little ways into this repair. This is a BenQ W1070, older but great projector. Even today, for a 1080p projector, these are still pretty great. This one was sent in to me because the customer had a lamp running, the lamp stopped working, they put a new one in, and the new lamp wouldn't come on. So they tried and checked all the normal stuff. They had actually opened it up and checked the color wheel and connections and a few other things, and were unable to find anything obvious. So they sent it to me, and this is the lamp assembly that I pulled out. This looks to be an original housing that they replaced the bare lamp or bare bulb in. You can see that's not a real bare lamp at all. That's some fake generic knockoff. It's not an Osram. This should have a 230 watt, 240 watt Osram. I can't quite remember. Let's look, because this is 210 watt. This is a good aftermarket lamp. This is not an original from BenQ, but the housing is made identically and has the right vents and all that, and most importantly, it's a real Osram, as you can see there. So I suspected that maybe the issue here is that the new bare lamp damaged the ballast. So we're going to check a few things, but before we do that, let's check the bare lamp itself and see if it fits the categories of a proper junk lamp. And look at that, 25 million ohms across the connections. It should be open. Let's disconnect the old wires altogether, move them out of the way so that there's no chance that they're involved. Look at that. Yeah, it's going up, that's good, but it should be open. It should look just like that. I should be able to touch these and not see anything. The other thing you probably noticed when I was touching it with the probes, wobble wobble, really wobble wobble. This bare lamp is another piece of junk. Probably blew up the ballast. So here's the aftermarket I told you about. Let's go to the contacts on that and see if we get, oh, look at that. A proper Osram has 0 ohms, not millions of ohms or thousands of ohms, no ohms, or I should say infinite ohms. It's above whatever a Fluke 87.5 will read. And just to show you all there's no trickery going on, I mean, I don't know why you'd expect any, but maybe if the manufacturer sees this, or somebody from Jaspertronics sees it, they'll know that no, they're just crap lamps. And this isn't from Jaspertronics, although they probably sell something similar. But anyway, so pulled the wires off. Let's get those contacts right on there. See? Nothing. Crap one right next to it. 25 mega ohms. Yeah, that's really high resistance, but it has to be infinite. These are arc lamps. There should not be any continuity through them. My guess is, well, I'm not going to pull that apart, but my guess is this is using that crappy conductive ceramic that all those knockoff junk lamps use. Don't buy your lamps on Amazon. Don't buy your lamps on Amazon. Don't buy your lamps on Amazon. Where should you not buy your lamps? Nope, wait. Yep, you're right. Don't buy them on Amazon. You got it. Buy them from any of the sellers listed on Projector Central under the lamp sales section. Anywhere else, you're gambling. So I'll put a link maybe right here or here, somewhere, that'll take you to Projector Central. And just pick the company that has the most reviews and the best reviews and the price that fits your need. Projector lamps are not supposed to be cheap. They're going to be reasonable, but they're not going to be cheap, because when they're cheap, you end up with junk like this, and you end up with a broken projector. So this is the lamp assembly we'll be using for the repair. Put that junk one off to the side. So let's put this in, and let's start doing our troubleshooting. Alright, so I was going to get my scope out and we'll troubleshoot with the scope, but I want to see if I can show you guys how to do this with just using a voltmeter. So the first thing we're going to do is check the color wheel sensor. Now on a W1070 or any similar chassis, the power to the color wheel sensor is on the right. That's the power to the LED. Center is ground, and left is the signal out. Now because it's going to be pulsing DC, then we're not going to see like a set voltage. It's going to be an average of the pulsed voltage. So we should see something like 0.5-ish or so. If we see 2 volts or 0, that's bad. So let's see what happens. Start it up. You'll hear the color wheel right there. So that's good. That's the color wheel. Sensor is running. I might actually pull out the scope just to show you. In fact, let me grab it. I'll show you. We'll do the troubleshooting with this, and I'll confirm with the scope so that you can see, you know, that you can use them, you know, that one is backing up the other. And before people ask, here is the scope. I got this on AliExpress, pretty cheap. It says 100 megahertz, but it's not really. It's like 50. So here you go. It's an FNIRSI model 5012H. I imagine it's a common used chassis, because I've seen this DSO software on other devices. So let's check it. Let's get a ground. Let's turn that power off. And let's see that again. Let's get ready. Let me go to 2 milliseconds. And then let's see. Let's go to 1 volt. Just make sure you guys can't really see that. There we are. All right. So power. As soon as I hear that color wheel, we'll check it. See? So we're getting 120 hertz there. So that color wheel is working, but the ballast is still not firing. So we see the color wheel, so that means the ballast should be firing. Let's check the lamp on signal to the ballast. Now here's a grossly simplified diagram of what's going on down here in the ballast section. So 5 volts here, lamp on signal. This gets pulled down. So this is 5 volts until it sees the color wheel spinning. Once the color wheel is spinning, you'll see this drop to about 2.5, 2.7 volts, somewhere around there. Pin 3, I'm pretty sure, is for power control, eco to standard. We're not really worried about that one. I think it's just going to be 5 volts all the time. And then the first 2 are actually the lamp status. This is what reports back to the projector that the lamp is running. Pin 2 is ground, and pin 5, I guess you could say, is like status positive. There's opto isolators right there. Those guys, and you can see 2 are facing one way and 1 at the bottom there is reversed. So the right one and center one are both inputs. They're controlling stuff into the board. The one on the far left there, that's a output. That's sending a signal back. That's controlled by the board and talking to the projector. So this is the interface. This is the part people have to cheat when they want to run one of these outside of a projector. So I actually have this one around in case that ballast is bad. I think it might be, but we're gonna check all the things first to determine. I'm not a fan of the part shotgun. You know, just taking all of your possible problem parts and shoving them in a cannon with a bunch of money and then blasting it at the projector. Not the way to do things. Take your time, troubleshoot, measure voltages, and replace the parts that are bad. Don't just start changing parts. Don't go online and, you know, see that some dude a few years ago had a similar projector and, you know, his ballast was bad and he changed it. Don't just run out and replace your ballast just because you saw it one place. I know it's tempting, but after 5 or 6 of those, you're $300 or $400 into a $300 projector, and you're ready to throw the towel in when all you had to do is take some voltage readings and you find out there's a loose wire somewhere or something. I don't know. You know, I don't think that's the case here, but I've seen it happen more than once. So anyway, let's check the signal to the ballast and see if I can get you guys a better shot here. DC volts, I'm grounded. So let's go to pin 4. Hold that on there. So as soon as I press power, well, within a moment or so of pressing power, we should see this go to 5 volts. And then once the color wheel spins up, we should see it drop. So there's our almost 5 volts. Alright, that's getting pulled down to 2.4. The reason it's reading 4.6 instead of 4.9 is it is going through that optocoupler, and those optocouplers drop about 0.3 volts or so. So we can see it tried to start and it didn't, you know, the status side didn't come up and tell it that the lamp had lit, so it let go of that control and let it go back high again, and now it's flashing the lamp light. So let's do it one more time. And the reason we're doing this is this tells us that the motherboard, or the main board here, is talking to the ballast correctly, and that the ballast is responding to the request from the main board correctly. If we didn't see that drop, or if the voltage was lower, then that might indicate a problem with one of those optocouplers. If it didn't change at all, then there might be a problem with the main board. So 4.7-ish, 4.67, 2.39, say 2.4. So it's trying, nothing's happening, lamp's not coming on. No lamp on signal has been recorded by the main board, so it releases that and lets it go back up. So that is working the way it's supposed to. It's talking to the ballast the way it's supposed to. So the next thing we want to do is check the power factor correction circuit feeding the ballast. We should see 380, 390 volts going into the ballast. So let's check that now. This one's kind of a pain to check. You need to get into the connector that's right here on the ballast. I want to make sure it's the negative is on top, positive is on the bottom. You need to put the probes right here. You can't use a ground somewhere else on the main board because the PFC ground is actually different from the rest, like the low voltage grounds. So you can't really get a valid measurement doing it this way. You have to really get into that connector. So what I like to do is just jam the probes down inside that Molex, give them a good poke in there so they're nice and snug. Get our power cord plugged in. Alright, and now this should go up to 380, 390. If I can get a good... Nothing. Why am I getting nothing? Oh, there we go. I didn't have a good enough connection. So 390. Let's do that one more time now that I have an actual connection. Pull that power cord out. Wait for everything to spin down. Plug it back in. Power. So 390. You actually see that voltage drop a little bit because that optocoupler is trying to turn the ballast on, but something's not letting it turn on inside the rest of it. So that tells us most likely an issue in that ballast. So let me pull that power. Let's move my leads. Let's get the meter out of the way, and let's take a look at this ballast. Now to get this ballast out, it's not super hard. It's just a little annoying. You got a screw here. I really should be using my screw gun for this. And then there's another one over here, but I'm going to try something that I've never actually tried before. The plastic that holds the ballast in place, and see if I can just slide the board out, because it would sure be nice to not have to take the rest of that stuff out. So let's see. Yeah, I think this will work. Oh, let's unplug the lamp wire. There we are, lamp is disconnected. I'll kind of wobble this out, because the screw, I don't know if you guys can see it, is down in there. Actually, maybe I can get it from a little angle here. Yeah. See, really, you want to take the main board and stuff out, you know, there, this stuff, to get to it. But if you can get your screwdriver in there on an angle, it's going to make your life a lot easier. And we'll see if Reassembly has a problem with that. Alright, so like I said, lamp connector, it's unplugged. Let's get it out of the little holder there. And then our DC high voltage from the PFC. And then let's unplug the control. And now let's get this, let's take this plastic bracket off, and then we'll slide the ballast out of this little holder. We'll just see if there's anything physically obvious. Nothing looks bad. Everything looks okay. But I can tell you these guys are freaking hot. Really hot. Yeah, this board's steaming hot. So I'll bet you these are shorted. You know, that would make sense with the lamp having continuity of having some resistance. That's no good. Let's unplug this control. And let's get the meter and see if these MOSFETs are bad. Alright. So like I said, those were really hot. You guys should be able to see. Alright, so these, there's 1, 2, 3, 1, 2, 3. So let's check gate to source first on both of those. See, they're measuring differently. I don't know if that really matters though. And I'm just looking for similarity. I'm not really worried about the numbers unless they're, you know, dead short like that. So let's see, 1.7 volt drop, 1.9, 2.13, 2. So we got 2. So between these guys, that one and this one are the same. There are the same. Here and here are the same. 2.1 and 2.1, they're the same. So what are we missing? I wonder if one of these other ones on the back here, like this guy right here, 1.13, that's the flyback diode. It actually, you know, seems okay. Let's check the other way. Let's flip the polarity around and see what we get, if we get anything. 0.5, 0.5, 0.5. 0.5. So it doesn't? Weird. Now I still think it's bad. I wonder if something else took the hit, like inside that output inductor or one of those capacitors. These are just getting so warm. Might have been those too. What I'm thinking we may do is try this other, and we might try this other ballast here and see what happens. In fact, that's what we're going to do. I am not going to fully reinstall it. We're just going to clip the wires on, set her in there, and see what happens. Yeah, we'll fire it up and see if it makes any difference. That lamp, a slightly resistive arc lamp, is never a good thing. So there could be any number of problems being caused by that. All right, let's plug this back in. I just hope this ballast is good. It has a question mark on the bottom, which means that I think it's good, that it came out of a working projector, but hasn't been tested. So if this one doesn't work, I actually do have another one that I'm more positive is working. All right, we'll just set that down in there. Oops. Let's get that wire back up and into place. I'll just set that down there. Plug that in. Set our system fan back in. All right, so let me slide this out and we'll plug it in. Let's see what happens. No. Hey, look at that. We have light and out of focus picture. There we are. Now we have in focus picture. So that's the problem. See, it's doing the signal search. So this is definitely our problem. We have bad ballast. My guess is either these are leaky, or maybe something on the control got damaged, or maybe one of those capacitors. These are the ignition capacitors. So, let's see those. It goes through there to there. Yeah, it could be. Could be one of those capacitors. I don't think we're going to bother fixing this. These are available. But what I do need to do is shut this back down and then remount everything. You know, put our little plastic doodads on for holding it, and just kind of button it up. And then I can do a reassembly, and the fella can have his projector back, which is pretty cool in my book. Actually, while this is cooling down, I want to bring up something that I hear from people a lot. Do not ever measure the lamp output voltage. Never measure the power coming out of the ballast to the lamp. These are arc lamps. They're using high voltage to ignite that arc. If you have your meter connected and you hit power and that thing comes on and it goes to ignite the lamp, there's a real good chance there's going to be 3 to 10,000 volts going through that. Now, if you notice, even on a fancy meter like mine, 1000 volt, 600 volt, 1000 volt limit for the meter. The probes, your wires, are even more of an issue. Same thing, actually, these are rated at 1600. You know, 1000 volts at 6 amps or 10 amps for category 3. if you hit these with 10,000 volts, you could shock yourself and really hurt yourself, kill yourself. However, more realistically, you're going to blow your meter up. And you're not going to measure anything of any substance. I just showed you really the best way to check a ballast. If you have your PFC, your 380 to 400, and you have the TTL control of your lamp on signal being pulled low, if those two things are happening, there's a real good chance you have a bad ballast. Measuring the output isn't going to tell you anything. And it's really useless. The output's also, it's a high frequency. It's running about 20 kilohertz, I think. So unless you have a special, oscilloscope that can measure that high, and with that high voltage, it's a total waste of time to measure the lamp output. Don't do that. Don't bother measuring. Don't bother putting your probes in here, where the lamp plugs in. These are not incandescent lamps. You don't check them the same way. Check your PFC input and check your control. If they're both good and you still don't have lamp ignition, and the lamp is good, bad ballast. So enough on that. Let's get this reassembled. Pop this up and let's slide this guy on. Make sure I get these on the right way. So this one goes on this side. And these just push on. They got the little tabs that grab. There we are. A little more. Come on. Alright, that's good. Let's see. That one's going to go there. Yep. And then this one goes here. I just wanted to make sure I didn't mix them up left to right. There we are. Yep. Let me just move the system fan out of the way. Make it a little easier to get all this stuff tucked in. Then plug in our PFC. Now sometimes this is easier to do with the other stuff taken out, but I've done it enough where I'm okay. So I'm not going to bother. There we are. That's in. That's in. Just get those wires back behind. Oh, I want to push them into that little... Yeah, there's that little cutout in the plastic to hold them. Alright, so let's see if I can get these screws in with having to take all this out. Alright, that one's good. Yep. And then, let's see, make sure that is in position. It is. Come on. Yep, I can get that on an angle. One of the nice things about Phillips screws, you can run them down on an angle like that pretty reliably. Alright, and that's going to get screwed down there. So let's put that fan back in. Alright. I like it. I like it, I like it. Alright, so then the screw that's got to go in here does not have anything to do with the metal shield that sits on top. It does, however, hold this ballast wire in place. So let's get that up underneath the ballast wire. Get that hole lined up. We'll snug that down. And then fold that over. That holds the ballast wire right there. Then we're going to get the metal piece that goes on top. Now this one got a little mangled. I think the owner may have been making extra sure or yeah, we're trying to pull it out without taking the back off, which I guess is also possible looking at the way all this is bent. Now this is all just shielding, it's really not that big a deal, so if we get it close, that'll be alright. The important thing is to make sure this, that, and these, and that go on the outside of the metal. None of these tabs go on the inside of this. Oh, crap. Before we put that in, I forgot to put a few screws in. Yep. I gotta take this back out. With all of my talking, I forgot to unplug that one. We need to screw that metal, the rest of that metal substructure back in, this piece. That takes these wider panhead screws. These guys with the that little washer kind of built into them. So we got one that goes here. There we are. And I am using a power screwdriver. I know a lot of people don't like these for this kind of stuff, but I've got carpal tunnel, so you know what? Too bad. This is the way I keep my carpal tunnel from getting worse. Now there's one more screw. It's going to go down here. You got to be a little tricksy about it, so that the there we go. It's magnetic. I didn't want it to get stuck on the metal, so I kind of have to just go for it. And then we have our ground wire over here. There we go. Let's get that folded where it should be. Now we can set the main board back down. We're going to make sure all those connectors are in the right spot. We're going to make sure the power pins in here don't get offset like they're trying to do. There we are. That goes down. Oh. There we go. That's all down. Let's plug that back in. There, and then blower fan. Everything else is plugged in, but let's get our... Actually, unplug that speaker so I can reseat this color wheel wire. And we're going to have to actually take that screw out. You know what? Let me take this color wheel wire out. Move it out of the way here. Because this screw has to come out so that we can put that metal shield on. I will, however, move that screw over to here because this strap and that ground piece to the ballast, that thing, they are not beholden to this structure at all. So we can just do this. And we're going to make sure that goes over like that. That. Let's kind of work our way around. Yeah, come on. There we are. Yeah, this thing got bent pretty good, but no big deal. All right, first let me put in this one. That'll keep it from rolling up. Then this one. Now these are going into metal threads, so I don't need to do that thing where I find the thread. I can just do that. What we will do though after these are in, I'll go around and make sure that this isn't bent down too far anywhere. Oh, you see? That is supposed to go here. Yeah, this whole metal underneath frame must have been bent because the screw holes are even kind of wonky with how they're lining up. And then this one. And then all of the top screws are in. And now let's set that color wheel wire back in and get that sensor wire ready to push down in there too. I'm going to put that sensor wire over top. So let's get that this way, and then we'll take this folded up flat flex for the color wheel and we'll pop that down. We'll plug this back in. And then we'll pop that in. And then we'll pop that in. We'll plug this in. There we are. That's good. Alright, so now let's put the side on. And before we continue, let's say hello to my assistant. This is Larry. Hey Larry. He's helping me. He's been keeping me company at work lately, so definitely making the days better. That's his little chair. Good boy. Yes. Oh, he's a good boy. Yeah. You guys have probably seen him in some of the thumbnails, but he's a good cat. And now he's going to go back to doing what he does best. Now we'll put the side on. They just kind of clip in. You got to line up those pieces. Now this was shipped in. It did not have any screws in there for the RCAs. I think I have some from old scrap units, but we're gonna get these started first. And you'll notice that yes, I'm using a flathead that doesn't really hold, but it puts enough friction so that you can at least get those started. And now we'll get the hand driver, that 5mm, and we'll just snug all those down. These are not very strong fasteners, so do not over tighten them. And I would recommend not using a screw gun unless you're very comfortable with how much torque your screw gun puts out. Alright, so then we just have the top screws to put in. So let me go see if I have one of those, and I'll be right back. There we go. Helical thread, tapered head. There we go. Can I get that a little more straight? There we are. Very good. Very happy with that. Let's put the top on. So this should be pretty easy. There was also a missing screw. Oh, that's why. The center was missing a screw, and I just realized that that had split and broke. Do I have another top? One moment. Okay, now we will put the top on. Now, unfortunately, this one has a broken screw tower there. The plastic bits are not inside, so I can't repair that. But that's okay. We have 1, 2, 3. Alright, so that side's broken and the center's broken, so we're only going to be putting 3 screws in the bottom and then 1 screw in the top. And that'll be okay. It'll be fine. It's not ideal, but it's fine. I thought I had another top around, but it's actually more beat than this one, so this one looks better. The other one's kind of yellowed from heat and stuff. So we'll just go around, snap that in. That's good. Back up. And I'm just squishing all the little edge clips back in. There we are. Wait, what was that? Oh, I wonder if that's one of the plastic bits. Oh, that's not good, whatever that is. Let's pop this back off and see what that noise is. Put that on, I just hate that. Okay, what just fell out? A bit of plastic that I suspect, because it was in that back corner. Ooh, we might be able to fix that. Definitely might be able to fix that. Let me get my shrink tubing and see if I have something that'll work. So I do have some shrink tubing. I put a little tiny piece of some smaller stuff over the end of it to hold that broken part in. Then we'll glue this to here and then slide that bigger piece over it, but I got to figure out how big that needs to be. So roughly about there. Cut it straight. And we'll just do a test fit here, see if I have to trim it down. Yeah, I have to trim it down a little bit. It was pretty close though. So let's just take just a little bit more off. Oh, not straight. Oh, so close. And we'll do it this way. Just kind of go around at the right height. There we are. Then I'm going to pull it back off. Then we get the super glue. Let's see if I can do this without gluing myself. And this is the thick stuff, so let's just get it on all the surfaces. Cap it. And then I know which direction this is supposed to go. I can see the lines, so let's just shove it on down there. And now I'm going to go hit it with the heat gun to shrink that down. Alright, so this is set to 200 C, which is a little high for shrink tubing, but that way I can shrink it quick. And this shrink tubing has that glue on the inside. It's like hot glue or something, so that when it melts and shrinks, it glues itself as well. So we should see some glue come squishing out of that end in a moment. There we are. That should do it. Yeah, that feels good. Feels snug. And that should fit. So this is good. Let's go and we'll put it back together. Alright, let's put the top on. Well, that is good. That's going to go down this side. We'll get that screw up through there. That'll be good. So, here we are. Set that. Come on. What am I missing? There we go. Oh, I think my shrink tubing might need to be trimmed a little. Let's pop it up and see if we have any witness marks that confirm that. Yeah. So I got to trim that down a little bit. Alright, that'll be better. And you know what, if it's not perfect, it'll be better than it was. Sometimes with these older projectors, there's a different level of good enough. Of course, you always want to get it as good as you can, but there becomes a point of declining return. So it's still pushing up a little bit, but hopefully when we put the screw in, that'll tie it down the rest of the way. So let's put some screws in. So first, we'll put in the good spots. That's these guys. Alright, that's in. Let's put in that one, and then we'll do the one that we fixed. Now, the one on top is shorter. I've showed this before, but I'll show it again. You can see that screw on the right is definitely shorter than the one on the left. And that short one is the one that goes in the top here. Now I suspect the long one will fit in here fine, but you know, the short one probably won't fit well underneath. So now this is the one we fixed. So I'm not going to jam on it. I'm going to take it down until I feel it grabbing well. There we go. And that's good. It's got a little bit, but that'll be good. I don't want to overdo it and break that worse. So now, all we have to do is put the lamp cover on. Now, I will have to talk to the owner about the lamp assembly. He's got to find an Osram, or he can buy this lamp. In fact, if you guys need one of these lamps, look down in the description. I'll have a link down there for, you know, one of these 5J J7 LO5001s with the proper Osram bulb inside. So this is good. Let's power it one more time before we take it over to the other spot and you know, make sure it's working with the signal. We should get a picture. It shouldn't be a big deal. Alright, I see it coming up. Oh, I got the lens cap on. There we go. It actually says BenQ now instead of a bunch of blurry crap. So this is good. Menu looks good. Get that a little focused. Yep, that looks good. Now we're in the service menu. Let's see if there's any errors recorded. We had 8 abnormal power downs and 10 lamp fails. So let's reset that error count. And let's get out of that menu. Let's turn her off. Oh, it's still coming up. You have to wait for these to start all the way before you can turn them off. Oh, come on. Come on. There we go. Alright, so I will be back with you guys in a moment, and we will check it with the signal. Alright, so I got it set up. Let's fire it up. Let's turn the lights off. And let's see what it looks like. Let's see, lamp comes on. Yep, lamp is coming up. Come on. Trying to do a dramatic camera shot here. That's a little big. Let's see, can we zoom it down? Not really, but we can focus it. And now I just have to find the right source. There we are, HDMI 1. There's the Raspberry Pi, and let's pull up a video. Alright, so now we're looking at a video of underwater. This is supposed to be 1080p according to YouTube. Let's see, it looks like it may have oh yeah, no, 1080. Alright, good. Just the over where the video gets out of the screen, it looked a little blurry, but I guess that's because it's not in focus. But we can see we have brilliant, wonderful colors right now. Lamp looks great, color looks great. I don't see any dust or anything. So yeah, this is good. So hopefully that sheds more light, pun partially intended, onto how to troubleshoot a BenQ W1070 Ballast, or most DLP projectors. You can follow those same steps. Those ballasts are fairly universal. You know, there's exceptions, of course. There's always exceptions, but by and large, if it's an Osram or Philips lamp, the ballasts use that same pattern of lamp on, status, power, that whole thing, and they almost all have that 380 PFC voltage. So follow those troubleshooting steps and you will know if you really need a ballast or not. And like I always say, where should you not buy your lamps? Correct, don't buy them on Amazon. Otherwise you end up with a broken projector. Always buy them from a reputable source. I'll have a link down in the description where all my lamps come from. And I'll also have a link to Projector Central if you want to, do your own shopping around. All of the sellers and the links for Projector Central, as far as I know, are reputable. I don't know them all personally, but Projector Central is usually pretty good about vetting their sources. So yeah, if you made it this far in the video, think about clicking that subscribe button. Don't have to, but it's free, But really, most importantly, thank you for watching.